Okay, so let's take a look at a little bit of the trig as well as the unit circle portion of this thing. So going back to the document, this time I'm going to write on it because these are pretty straightforward, quick questions. So keep in mind that as we've gone through this information, the sine of theta is always its y value upon the unit circle. The cosine of any angle of theta is always the x value on the unit circle, and the tangent is the ratio of those two, the y over x, because remember it's TOS, opposite over the adjacent. So as we go through those values, I'm just going to think of the reference angle, and I know at pi over 4, both the x and the y are both root 2 over 2. So I know that the cosine is going to be root 2 over 2. But 3 pi over 4 is in the second quadrant, and since it's to the left and the x value is negative to the left, that's going to make this value negative. Now, in the same way, I know that the sine of any kind of pi over 3 based on our unit circle values is going to be root 3 over 2. But I have to decide about positives or negative. Now, if we look at the unit circle, this value right here is 1 pi over 3. But as I rotate around, this would be pi, which is 3 pi over 3. All the way to here would be 6 pi over 3. So 7 pi over 3 is the value just past a full revolution. So we're just in the first quadrant, and we know that everything is positive in the first quadrant, but it's also positive because the y value is up. So it has to be a positive. Now, the tangent of the pi over 6s is one of those values that's a little bit unfortunate. It helps to memorize these facts that the tangent of pi over 3 is root 3, and the tangent of pi over 6 is root 3 over 3. It's a little bit unfortunate. There are a couple of ways that you could know that based on the shape of the tangent wave. But again, 5 pi over 6 is in the second quadrant, again, just shy of pi, which would be 6 pi over 6. So since it's in that second quadrant, it is the ratio of a positive y and a negative x. That's going to yield a negative answer. And then last but not least, you need to know that a cosecant is really just a sign that has been flipped over. So it's going to be 2 over root 3. Now keep in mind this is a positive value because pi over 3 is in the first quadrant. And we usually choose to rationalize that problem and make it look a little bit better. So 2 roots of 3 over 3. Cool. Now, down here, we're looking for values between 0 and 2 pi. So keep in mind, these are cyclical functions or periodic functions that repeat over and over and over. So when you're looking for the solutions to equations in inequality and trig, you get infinite numbers of answers because the wave just keeps doing its thing over and over and over again. So we're not going to look for all of the answers. We're just going to look for the primary answers that would be repeated for all eternity. So quite frequently, you'll see this little thing is just saying, let's not go crazy. Let's just get part of it. So you can see that this sort of looks like a quadratic, as does this one over here. So what I'm going to do is I'm going to choose to factor this thing. Because that's, I think 2 sines times a sine would be 2 sines squared, and it kind of makes sense. In order to yield the number 3 in the middle, I could go this way, because a 4 and a 1 would make a negative 3, as follows. And so the only way that this would be true is if the sine of x was 2, which is completely impossible. A sine wave oscillates between negative 1 and positive 1. It'll never reach 2. There's no solution to this portion. But it also happens when the sine of x is negative a half. So again, the sine is the y value. So we know the y values have to be below, so it has to be underneath the x-axis. It has to be versions of pi over 6. That is its reference angle. So that's going to be 7 pi over 6 and 11 pi over 6. And I'm going to have to pick this one up because I'm out of time. All right, I'll be back later.